Alright, so I need a video to actually convince you that this is useful. So let's do a much harder example. Or at least it seems much harder. It seems like a very hard question when it's first phrased this way if you don't know Green's theorem. So we want to find the area enclosed by this weird parametric curve that we've never seen before in the range t from 0 to pi. So that's difficult. Do we even know how to graph this? It's actually pretty difficult to graph general parametric equations. That's a problem that a lot of people have a lot of trouble with. Let's just think about what's happening. Let's draw a little unit circle off to the side. So sine 2t, what's the relationship between sine 2t and sine of t? Well, the angle's always ahead, right? So as long as if 2t is between 0 and pi over 2, then the x-coordinate is going to be greater than the y-coordinate. Okay, up to at pi over 2, so r of pi over 2, and we're going to start at 0, 0, right? R of 0 is 0, 0. At pi over 2, we get to, at pi over 4. T is pi over 4, 2t is pi over 2. Then we get to sine of pi over 2 is 1. Sine of pi over 4 is 1 over root 2, or about 0.7. So, okay, we start at 0, 0. We're going to go to the point 1, comma, there's 1, 0.7. So there. So here, the x, like, let's say that's the line y equals x. Then the x-coordinate is always going to be greater than the y-coordinate. You actually don't know that the curve looks like this, but I do because I've looked up the graph. So very difficult to figure out what this is. And then gradually, as we pass this, eventually the x and y coordinates will be the same, and eventually, actually, the x coordinate is going to go to 0, and that's exactly at r of pi over 2, because then we get sine of pi is 0, and sine of pi over 2 is 1. So we're actually going to end up at the point 0, 1 eventually. So, and then we're just going to repeat that, but the y-coordinates will be the same and the x-coordinates will be negative because now we're down here. So we can deduce that it's a mirror image of itself. So what is the question asking? Well, after a lot of work and a little bit of looking stuff up, which is tough, we know that we're trying to find the area in here. So we've drawn a picture that actually doesn't even help because I don't know how to do that. This isn't a vanilla polar integration. We don't know what the curve is. Okay, so maybe I just need what the curve is. So I have x equals sine of 2t and y equals sine of t. Can I get that as one equation where x and y are related? Maybe. This is 2 sine t cosine t. So I like the sine t. I can put y in there. I don't like the cosine t, but maybe if I square it, I can swap out cosine for sine. Okay, so x squared is 4 sine squared t cosine squared t, which is 4 sine squared t, and then cosine squared t is 1 minus sine squared t. Okay, so now I can sub in y for sine t, so I've done it. I now have this equation. Now when if I square and take a square root, I might be messing with my graph. Here I actually am. If you go ahead and try to plot that, which is also really hard to plot by hand, you actually get the bottom piece as well. So the plot of that is this weird figure 8 type thing. So I've actually gained double the graph by going to there. Maybe not good. Also not helpful. I don't know how to integrate this. Oh, maybe I do. I can take... Okay, so if I just take x is the root of that, it's actually better. Root of 4 y squared 1 minus y squared. No, I want to take y as the root. I want y to be positive, or greater than or equal to 0. Okay, so there's no good way. I don't know how to find this area the regular way. I can't figure out an integral over the region of 1 dA, a way to do that. So I'm going to use my Green's theorem trick, where I go, like this. I'll just keep using my favorite one until it stops working. So this is x dy. Okay. Oh, this is great, because now I know what x is in terms of t. I know what y is in terms of t. I know what dy is. dy is cosine t dt. This is so much better. Okay, great. So now I am, and then the boundary of r is just as t goes from 0 to pi, everything seems to be good suddenly. Okay, x is sine 2t, dy is cosine t dt, and this is now a totally doable integral. All this stuff over here, I didn't even know how to set up an integral that was doable. Okay, this is now totally doable. I'm actually going to use the trig identity 2 sine t cosine t. So this is sine t, cosine t times cosine t is cosine squared t. And then I can just do a quick u sub. U equals sine t, or u equals cosine t. And then du is negative sine t dt. So that means sine t dt is negative du. And I can sub that in. So I'll have a negative 2 integral from 0 to pi. That's negative du. This is u squared du. Okay. So then negative 2, and these are still t bounds. So I'm going to do u cubed over 3, going from t equals 0 to t equals pi, and then I'll plug cosine t back in for u. So I get minus 2/3 cosine cubed t going from 0 to pi. Cosine of pi is negative 1. Cubed is still negative 1. So I actually get a positive 2/3 minus a negative, so plus 2/3 cosine cubed of 0, which is 1 cubed, which is 1. So the answer is 4/3. Okay, so that's kind of cool. This region that we barely knew how to draw a picture of, we can find the area of with Green's theorem.